Okay, so we are going to look at the PackML MQTT simulator feature that's packaged with the UMH. So to first begin, I will give a short overview of what exactly this PackML feature does, and then we will move on showing the final result so you get a better idea of what we are trying to do here. So the PackML simulator, you can find it on this GitHub repository, which will be linked to the video. And essentially, it's a virtual production line with a machine. This machine can have multiple states, from execute, where it's producing goods, to, for example, complete, or being idle, where the machine stands still. There are many different states, as you can see here in this image below. We are going to transition from one state to the other, and this of course will change the behavior of the machine. For instance, when the machine is producing, the machine's speed will be high in the state execute, and when the machine is idle, the speed will be 0 because the machine is not producing. Now, besides having states, we also have signals that will cause a state transition. For instance, when we are currently in the idle state, when the machine receives the signal start, it will transition from the idle state to the starting state, and so on. Now, certain transitions happen by themselves. For example, from starting to execute, it will transition after a few seconds. Those states are mostly shown by the SC commands here, which means that we do not have to send them ourselves. The reason why we are looking at PackML is to try to visualize the state transitions, but also the values of the machine. So the machine speed, the parts consumed, the parts produced, and also the parts scrapped. We want to have a nice dashboard that gives us all the informations in real time. To conclude the discussion of PackML, in the GitHub repository, you can find the documentation about all the different commands, their status of the machine, and things like admin, where you can check the current PackML state, and so on. Now, moving on to what the final result will look like. I have here on the left a dashboard that I have built in Grafana, which comes packaged with the UMH. What I'm going to do next is I have here on the bottom right my MQTT Explorer open, which is just an open source tool that allows you to interact with your MQTT broker and send commands. And let's have a look at the command tree here. So I'm connected to my broker on my local IP address. In the text location, default area, and the production line, I see that under the status tags, I have a bunch of tags. So the current state is in execute. Let's send the command complete first to I'm currently in the suspended state. All right, so currently I'm in the state suspended. Now I'm unsuspending, suspended. And we can see the actual values on the left of the dashboard. So let me try to get the machine in an executing state and see if we can see the machine speed increasing, and if we can see the raw material, the finished goods, and the scrap being produced. Right, so now in suspended state, I'm here in the diagram, this yellow box. To go to an unsuspended state, I have to send the unsuspend command, as I can see here on this arrow. So unsuspend, suspend, right, with the value 1. I'm publishing it, and I see now I'm unsuspending. This value also has been picked up by the state log. The machine speed is increasing, as we can see in the diagram. And we are currently in the execute state. And the dashboard shows as well that we are in the execute state. Let's refresh the last 15 minutes. Right. And I can see that the raw material is being consumed. I'm producing finished goods. And unfortunately, I'm also producing some scrapped goods. I can see my current machine speed and the current machine state. Now let's try to put the machine on hold. I'm currently in the execute state. To get to the held state, I have to pass through the holding state by sending the hold command. So I'm sending a hold command with the value 1, publishing it to the MQTT broker, and we see that indeed he picked up on the holding state. My dashboard did so as well in pretty much real time. Don't forget that the Grafana dashboard refreshes only every 5 seconds. And I'm currently in the held state as shown in the broker, and I also see it in my dashboard, and the speed is 0, it's non-existent. Right, so this is the final result of what you can do with Grafana. You can nicely visualize data that would otherwise be hard to see. In the next part, we will explore how to actually build this dashboard with the various components of the UMH. Okay, now that we know what the final result should look like, let's try to build it from scratch. This will consist of configuring the required flows in Node-RED that will read data from the PackML simulator and write it to the unified namespace, and then automatically write it to the timescale.db historian. Once the data is available in the historian, we will use the new data source in Grafana to build the desired visualizations. So let's get started. I have here open my Proxmox window in which I can see I have one instance of the UMH running in Flatcar, and its IP address is 192.168.178.169, and this address we will need to connect our MQTT Explorer. Just to remind you, the MQTT Explorer is an open source tool that you can use to inspect your topics and also send signals. So in order to connect to our broker running in the UMH, I will input the IP address I saw earlier in here for the host. The port can be left by default because the UMH stack exposes the broker on port 1883. The username is core with the super secret password UMH. It's the default user. So let's go ahead and connect. And now we can see that for the test location, we have our PackML data with the status and the admin. If in your installation, you're currently only seeing a machine speed of 0 and you don't see the other states, for example, state current or the unit mode, what I would recommend is check the state current string and make sure it's something like execute. If it's currently in idle, you may have to send a command like start that you can do via this publish feature. So by specifying this tree here and sending the command, for instance, start with a value of 1. Right, so we are connected to our MQTT broker. We can see the signal tree, so the topic. Now let's take a look at Node-RED. I have here an empty flow diagram in which I will read data from the PackML simulator and then write this data to the unified namespace with a particular topic structure, so that this topic structure will be written automatically to timescale.db, the historian. So let's get started. I have here my MQTT in node. Let's make it a bit bigger. And this is where the MQTT Explorer comes in handy, because it shows us what the topic is on which the data lives from the PackML simulator. So I see that the topic I will need is gonna be under test location / because in MQTT the convention are forward slashes, default area / default production line. And let's say we want to visualize the current machine speed. So that's this signal. It's a floating point that is basically sent every second, every few seconds. So this lives under status and / current machine speed. Okay, there we go. Now, we can't just read this raw float into the historian. We need to know what the timestamp is. So essentially, when as data appears here as a floating point, we want to add a timestamp in milliseconds so that the database can save it with the proper timestamp. So for this, we will use a function. So I'm creating a new node in Node-RED. There's a function. Let's open it. And essentially what we are doing, we are going to adapt the message a little bit. Currently, the message that I'm receiving is just a floating point. Let's name this function add timestamp milliseconds, right? So what we're going to do is we're going to overwrite the payload of the message. For this, we will actually create a JSON object in which the first element will be our timestamp in milliseconds, which will consist of just getting the current timestamp in the system by using date now, comma, and then the second value will actually be our current machine speed. So let's name it current machine speed, double point, and this will be the original payload. Because remember, the original payload was this floating point. Okay, this looks good. Let's click on done. And what I always like to do is, if I'm creating a new flow and I want to know how it looks like, we can use a debug node. A debug node is essentially like a print statement. It just shows you the values that are coming out of the previous node. So I connected my debug node to the add timestamp millisecond function. So if I deploy this flow, I see that indeed my message looks like, yeah, a JSON object where I have a timestamp and the current machine speed. So this looks good. We can move that over here. Now, the next thing we have to do is that we want to write this converted message into our unified namespace. And we want to be smart about selecting the topic, because if we pick the topic carefully, we can make sure that the unified namespace will automatically save all of these messages in the timescale.db historian. So for this, let's have a look at the documentation about the unified namespace on the UMH documentation website. We see that the topic structure should follow this convention. It always should start with UMH and then version 1 if we use the newest data model, which I would definitely recommend, then enterprise, and the rest of the cells are optional. But the final point is interesting. We see that the schema should be _historian for the data to land in the historian. So let's build a topic like that. We're gonna go back to Node-RED. I'm going to select a MQTT node and put it here. And here we will specify the topic via the convention we looked at earlier. Now I have it saved on my clipboard. And essentially the topic I'm going for will be UMH and V1 and test enterprise, as those values are obligatory. And then I'm going to add it under test site, test area, test line, test work cell _historian, because I want to save it in the historian. And then I will provide a tag in which all of the, let's say a group tag in which all of the tags of my PackML Node-RED flow diagram will land. So let me just call this one PackML as a tag. Okay, we can click on done. Let's connect the nodes and redeploy. Okay, so what's happening now is that data is coming in from the PackML simulator service in the UMH. It's getting slightly transformed. We're adding a timestamp and creating a JSON object. And this message is being written in a unified namespace. And because we have here the historian component in the topic name, it should also automatically be written to the PackML tag. Right. So in the next phase, we can actually try to explore the result to verify it. And a very convenient way to do it is to rely on the management console's tag browser. So let me go to the management console. I have here my PackML instance running. This is essentially the instance in the management console that is connected to my UMH installation running on Proxmox. And here in this window, to make it a bit bigger, we can go to the tag browser and we should be able to find our PackML tag here under Enterprise, Test Site, Test Area, Test Line, Test Work Cell, and then in the historian, indeed, I see I have a PackML group tag which shows me the current machine speed. If I click on it, I actually see I get a nice dashboard which shows me this value in real time. So I think that's a really cool feature. Right, also what I can highlight now is that should you want to display this data in Grafana, the tag browser automatically generates the query that you can then use in Grafana to display this data. This is in fact what we will do right now. So let me move on to the next step, and that's the Grafana dashboard running on 8080. And let's create a new dashboard. I click on New, create a new dashboard. Let's add a new visualization. And given that we are visualizing the floating point of the current machine speed, let's display this value as a time series, which is conveniently selected by default. Right. And as I said earlier, we are going to use the most recent data source, which is the UMH timescale DB at the time of this video, which is also the default data source. And instead of building the query ourselves, we are just going to click here on code, and we will be able to copy the code in this window. Let me move myself up here. So I'm going to go back to my tag browser in the management console. I'm going to copy this to my clipboard. I'm going to move back to my Grafana dashboard and just paste this code over here. So now when I run my query, we see that indeed I have the data visible in Grafana. There's a couple things we can do. We can call this the current machine speed as the title for this particular window of the dashboard or visualization, and click on apply. And that looks good. Let's see if we can save this dashboard. Let's call it PackML tutorial. Save. And here we go. We have the current machine speed. We can say we're going to use the last 15 minutes and we're going to refresh the dashboard, or we're going to make it refresh every 5 seconds. This is essentially the whole process from A to Z, how you create the flow in Node-RED and then finally browse the SQL query in the tag browser of the management console, and then how you create a dashboard with a visualization in Grafana using that copied SQL code. Just for the hell of it, we can create a second value that we want to display. Let's have a look at our MQTT Explorer. And I think it would be interesting to, for instance, display the number of consumed products. So the product consumed count. And for this, we will navigate back to Node-RED. Let's hide this. And it's going to be pretty similar. We are going to copy these two nodes, place them here. And there's a couple things I have to change. First of all, we are no longer looking at the current machine speed and the status. We are instead looking at the admin topic. let me read it again in the MQTT Explorer. So admin, the product consumed count. Oh, that doesn't work. So prod consumed count. Then there was a /0 and it's called count. Okay, and there we go. Place done. Again, we have to slightly modify the function in the sense that we are now no longer sending the current machine speed. We are sending the prod consumed count as the message payload. Let's click on done. And let me quickly, to be sure if everything is correct, connect again my debug node to the end of this function, clear the window, and hopefully here we will see that indeed we are receiving a timestamp and the product consumed count. So what we now will do is we will connect this to the same group tag PackML, and hopefully this data will be also available in the historian and the unified namespace. I'm going to redeploy, and let's go now to the tag browser here. In my historian for PackML, I see that now I have a second signal, which is the product consumed count we just created. I can click it here, and we see that it's again growing in real time. Okay, so this data is available in the unified namespace. It's being written into the historian. Just as with the machine speed, we can go ahead and copy this query here. I will move to my Grafana tab, and let's create a new visualization. Again, we can place the code here. I will paste it the same place we did earlier. So here. And instead of a time series, because essentially it's just a number, let's do a different visualization. Let's make it a gauge, why not? So let's run the query, and now we see that we get this number as a gauge. Let's click on apply, and there we go. We see now that we have a dashboard with two panels, the current consume count and the current machine speed. Just as earlier we did, we sent signals. We can now also, for example, send a signal to suspend the machine from an executing mode to a different mode. So I'm sending the command suspend with the value 1 and see what's happening. So the machine is now suspending, which should mean that the current machine speed will go to 0. And there we go, we see it happening in the graph. Alright, that's all for this video. I think you have everything you need to start building your own PackML dashboard.